In Chapter 7, Section 2, you're going to learn about properties of exponential functions. Now, when we talk about properties, I'm going to teach you how to stretch, compress, move left and right, and up and down the graph of an exponential function. Let's take a look at the example that the book provided for us. We have the two graphs here. We have y equals 2 to the x power, and y equals 3 times 2 to the x power. It should be no doubt to you that this one would be vertically stretched by a factor of 3. So if you look at over here, okay, you see this real tall one, the one that goes up a lot faster, that's the one that's stretched by a factor of 3, this one. This one here, the y equals 2 to the x, that's the original. So this one's the original, this is the one that's been vertically stretched. Now, how do the y values change? Take a look at the original y values. The original y values, here they are, this is the original. Look at every single y value in the next column. Everything's just been multiplied by 3. Let's go down and try some of these ourselves. Look at problem 1. How does the graph y equals negative 1/3 times 3 to the x power compare to the graph of the parent function? Well, you should probably know that the parent function is just with this right here gone, like as if negative 1/3 are really just a regular 1. So the parent function is y equals 3 to the x. Now how should it compare? Alright, let's take a look at it before we even graph it. The negative is going to make it reflect around the x-axis, just like it always does. And the 1/3 is going to vertically compress it. Let's go ahead and do some math and get some values. Let's talk about the original, or the parent, first. Plug in negative 2. You get 3 to the negative 2 power, which you should know by now is 1/9. Plug in negative 1. You get 3 to the negative power is 1/3. Plug in 0. You get 3 to the 0 is 1. Plug in 1. 3 to the first is 3. Plug in 2. 3 squared is 9. Now all of these values here are just going to be multiplied by a factor of negative 1/3. So if you take what we got for this circle right here, what we got for 3 to the x power, just multiply it by negative 1/3. So if we take what we had, okay, and we do negative 1/3 times, we had 1/9, we now get negative 1/27. Okay, take negative 1/3, multiply it by what we had, 1/3, and now you get negative 1/9. Take negative 1/3 times what we had, 1, and now you get negative 1/3. Take negative 1/3 times what we had, 3, and now you get negative 1. Take negative 1/3, multiply by what we had, 9, and now you get negative 3. I do want to plug in 3, so let's plug it into the parent. 3 to the third is 27. That's really large. We're not going to be able to graph that. But if we take negative 1/3 times 3 to the third, which we already have is 27, we get negative 9. Let's show how those two graphs are so significantly different. If you have colored pencils, this would be the time for you to get them out. I will always put the original in red, and I always will put the other one in blue. Alright, the original is negative 2 1/9, so it's really short right there. And then negative 1 1/3, and then 0 1, and then 1 3. Remember, this is the original. 2 9. Plot your points and connect. You should have an exponential graph that grows fairly quickly. It approaches the x-axis, but remember it never touches. Let's plot our new points. Negative 2, here it is, negative 2, negative 1/27. That just means it's super duper tiny. It's very, very, very small. Negative 1, negative 1/9. Still very small. 0, negative 1/3. Still very small. 1, negative 1. 2, negative 3. And then if I had enough graph, you could see that 3, negative 9 would be somewhere down here. Graph them. and you can see that it has been kind of like compressed, what I mean is it's kind of been like stepped on, and it's also reflected around the x-axis. Okay, so this one has been vertically compressed, and it's been reflected. Okay, let's try it one more time. I should probably write our parent function. We have a new y equals, okay? This is the new one, and it came from the original of y equals, just take away the original a, 5 to the x. This one would have been the original or the parent function. So how are these different? How is the blue and the red different? Well, let's talk about the negative. The negative is going to make it reflect around the x-axis, and the 0.5 is going to vertically compress it by a factor of 1/2, because 0.5 is 1/2. Alright, so we have our original, or our parent, of y equals 5 to the x power, and we would plug in these x values. So I would plug in 5 to the -2, I would plug in 5 to the -1, 5 to the 0, 5 to the first, and 5 squared. I would get out 1 over 25, 1 over 5, 1, 5, and 25. And then for the new one, okay, this one is y equals -0.05, 5 to the x. I just take all these things and I multiply them by -1/2. So this one becomes -1/50th. This one becomes -1/10. This one becomes -1/2. This one becomes -5/2, which, by the way, when you go to graph it, is the same as -2.5. That way you know what you're graphing. And this one would be -25/2, which, as you should know, is -12.5 when you go to graph it. Let's plot our points of the blue one only, okay? This one we are only going to graph the second one. Okay, we're only going to graph the second one on this one. So I do -2, -1/50th, so that's super small. -1, -1/10th, again, very small. 0, -0.5, which is right here. 1, -2.5. And 2, -12.5. Which is somewhere down here. Draw your line. And you should notice this thing, if we graphed it and compared it to the original one, this one is about half as tall. It means it's kind of compressed, and it has been reflected. Now we can also move graph left and right, and that's left, right, up, and down, and that's what we're going to do in problem number 2. So take a look at problem A. Okay, this one I would circle in blue because this one has been changed from the original. It would have originally, it would have been y equals 2 to the x power. That would be it. Okay? So let's talk about how it's changed. What are the transformations? Well, the only number that's been added is the -4, and the -4, just like it used to, it moves it to the right 4 units. Alright, so if I make an XY chart, remember I usually plug in these numbers over here. These are my usual. These are my usual numbers, but since it's moving to the right 4, okay, these are all going to move to the right 4. So, I am instead going to plug in 2, 3, 4, 5, 6. Okay, let's plug in 2. So I'll get 2 times 2 minus 2 to the 2 minus 4. Well, that's really 2 to the -2, which is 1/4. fourth. Let's plug in 3. 2 times 3 minus 4, or 2 to the 3 minus 4, is 2 to the negative 1, which is 1/2. Let's plug in 4. That's 2 to the 4 minus 2, which is 2, which is 2, that's 4 minus 4, which is 2 to the 0 power, which is 1. 2 to the 5 minus 4. 5 minus 4 is 2 to the first power, which is 2. Plug in 6. That's 6 minus 4 is 2 squared. That's 4. Let's plot our new points. Over 2, up 1/4. Over 3, up 1/2. Over 4, up 1. Over 5, up 2. And over 6, up 4. You can see that this is a very general slope. Okay? Make sure you have it approach the x-axis but never cross. And you can see that this has indeed moved to the right 4 units.